This video is to go over where a graph is increasing, decreasing, or constant, and we're going to do that using interval notation. So we're finding those intervals of where the graph is changing. So the first thing you need to know is that we only use x values when we're finding these intervals. And so we read the graph like we read a book, which is left to right. And that's why we use the x values, because that x-axis goes left to right. So if it's an increasing interval, the graph is moving up left to right. So it would look like this. If it is decreasing, it's going down. And it doesn't have to be a linear function. It could be a curve. So if it's decreasing, it's going down left to right. And if it's constant, it is, I'm going to say flat left to right. And constant looks like this, perfectly flat. One helpful way to do this is to use different colors, so highlighters or markers or something. So I'm just going to outline mine in different colors. I'm going to use highlighters. So I'm going to have yellow for increasing. I'm going to use green for constant, and I'm going to use pink for decreasing. So what I typically recommend is pretending you're a little stick figure guy, kind of like this one I have here on this image. And imagine that you're walking on a journey left to right. So you start out traveling, you're walking this way, then you would be walking here, and then you would be walking this way. So we're always walking left to right on our journey. And so if I'm the little stick figure, I'm starting by walking up. So I'm increasing. I'm going to highlight yellow. Then it's flat. And then he would be walking down. And so that is how we determine increasing, decreasing, and constant. And I'm going to use open interval notation. And this is highly argued in the math community. I don't know why. But I'm going to stick with doing it the way that the majority of what I see in upper level math, so Precalculus and beyond, the majority of textbooks and teachers use open interval notation. And so what that means is we typically just use parentheses. We don't often use brackets, especially for turning points. And so what I mean by that is it's increasing from the left, and we call the left negative infinity. That arrow is pointing left forever. So you would have been walking upwards forever on that side. And so that's negative infinity. Now we always use open interval for infinity symbols because they're not a physical part of the graph. We don't know what infinity's actual value is. And then as you walk up this graph, you're going to stop walking up at -2. Again, we use the x value, not the y. You can pretend the y-axis doesn't even exist. And so I'm turning to constant at -2. I'm going to use a parenthesis. So normally in domain and range, you would see that as a bracket because it's a physical point. But in interval notation, we often don't because it's changing right there. You can't really say it's increasing or constant, so we just leave it as a parenthesis. So just using parentheses in this video, it is constant from -2 until this x value, which is 1. So from -2 until 1 are the x values where it is constant, and then it is decreasing starting at 1, and it's going to decrease forever to the right, which we call infinity. All right, let's practice some of these. Feel free to pause and practice on your own before I reveal the answers, and I will probably go a little bit faster than I just did on that one. All right, so increasing, I'm going to highlight yellow. If I was a stick figure and I was on a journey and here I am, I'd be walking up, and then I would turn right here. That x value is 1. And I would be walking down. And so I am increasing from the left side, which we call negative infinity, until that turning point, which is 1. I'm then going to be decreasing. And so I am going to call that 1 to infinity. I am decreasing for the rest of the graph. And it's never constant. All right, so my next graph, if I was a stick person and I'm on a journey, I walk from the left side. When I hit the graph, I'd be walking only one direction, and that direction would be downward because we walk left to right. Often I have students say, but the arrow is pointing up. It doesn't matter. You're reading it left to right. So if you hit this graph and you go towards the right, your path going towards the right is to be going down. And so it's always decreasing, it's never increasing. And if it's always doing the same thing, it's just the entire domain. And for this graph, it would be doing that forever, left and right. So negative infinity to infinity. For number 3, I'm going to be turning. I like to find my turning points. My turning point is at 4. And if I'm that stick person and I'm on my journey left to right, I hit this graph and I start by walking down, and then I would turn and I would walk up. So I start by going down this U-shaped parabola, and then I would go up it. And so it's increasing from 4, because that's where it turned to start going up, until infinity. It is decreasing from the left side. We call the left side, if there's an arrow, negative infinity, and then it also turns at 4. So we don't use a bracket at 4, but again, because it's a turning point, we can't really claim it as either increasing or decreasing. It's just turning. All right, let's do some more. Number 4, we've got 3 things happening here. If I'm my stick person, here I go. I hit this graph. I'm walking down. Then I'm walking on a nice flat constant area. And then I'm walking up. So oopsie, I totally messed up my colors here. I should have put purple on this side because that was my decreasing color. Got ahead of myself. Then I'm constant, and then I'm increasing here. Forgive me for that. All right, so I'm increasing starting at this turning point. That is at 2. And I'm going to increase forever to the right, which we call infinity. I am decreasing from the left. We call that negative infinity. And it turns at negative 4. Again, I can say left, like all the way to the left and all the way to the right, because I've got those arrows, meaning it goes left and right forever. It is constant from negative 4 until 2. All right, number 5. I'm a stick person. I'm walking left to right. Here I am. I hit the graph. I'm walking up the whole time. I'm always increasing the whole time. And if it's always doing one thing and it goes left and right forever, we just say negative infinity to infinity. For number 6, when I walk onto this graph, I would hit the graph and I would start by walking up it. Then I turn at negative 2, and then I would walk down. So the increasing portion of my graph is from the left, negative infinity. There's an arrow, so it's left forever. It turns at negative 2. It turns at negative 2, and then goes down the rest of the time to positive infinity. Now, again, this is the area where I have students say, but the arrows are going down. Wouldn't it be decreasing from negative 2 to negative infinity? No. This is talking about the x-axis on the right side. It's continuing to get positive in the x values. That's why it's a positive infinity. You will never see a negative infinity on this side of the interval. You'll never see a positive one written on that side of the interval because you can't go left positively and you can't go right negatively. There's nothing constant about that graph. All right, our last 3. Number 7, we are a stick figure on a journey. Here we go. We are going to start by walking up. Then we're going to flatten out for the rest of the time. So I can go ahead and say it's never decreasing. It turns at negative 3. I'm increasing from the left, so negative infinity until negative 3. It is constant from negative 3 forever to the right, which we call positive infinity. Number 8, I am only doing one thing. Here I am. I walk onto my little graph. I'd be walking up. That's increasing. So I look and see where it starts. Now, guys, this is where the debate on to use a bracket or not comes into play. Some people would say, well, 4 is the whole graph is increasing. There's no decreasing, there's no constant. So they might say you need to use a bracket here for the 4. I'm okay with that. You will see it written both ways. If you were to Google this topic or use one of the apps, you'll see it both ways. So on this one, I'm going to put 4 to infinity, or you could, if you want to, you can include that it could be with a bracket, but often we use just a parenthesis. All right. This last one is wild looking, right? It's a rational graph. There is an asymptote at -3. An asymptote, if you're not familiar, just basically is where the graph is curving into this line that it's never going to cross. And so it's never going to be defined at -3. And so that's important. But if I'm a stick person on a journey, and here I am, I walk down on this piece. And if I'm up here and I hit the graph, I would also be walking down. So it doesn't look like they're both decreasing, but they are. You would walk down or you would walk down. And so both of these are decreasing. So it's always decreasing. And it does go left and right forever because of those arrows, but it's never going to be -3. So the way we write this is never increasing. It's never constant. It's always decreasing. I know it looks flat, but it's really just continuing to decrease by really small fractions. As it's decreasing, it decreases from the left, which is -infinity, and then it stops before it gets to -3. Then it picks back up -3 to infinity to the right. And what that says in math language is all the numbers except for -3. We use that union to put them together to say, hey, this section and this section. That's all that U is. So this is increasing, decreasing, constant.